Hi! Today we're going to talk a little bit about physical and chemical properties and physical and chemical changes. We've actually done a little bit of the physical properties before here. We talked about density, boiling point, and melting points. Physical properties are ones you can identify by looking at a substance or by just like doing a simple observation of it. Like taking its mass or taking its volume, and you can use that to find density. But for a chemical property, you don't know those unless you do some sort of experiment with it. So a chemical property will describe how a substance reacts with other material. Maybe that's one of them. It could range from simple reactivity to maybe even like flammability. That's another chemical property. You don't know how a chemical is going to react. Like, for example, this is a gold ring. I don't know if it's going to react with water unless I put it in water and find out, right? So obviously a lot of these we already know, but not all of them. And if you wanted to find something out, you would have to do that, or you'd have to look it up to see if someone else has done it already. Chemical properties are related to the specific elements, and they describe how a substance changes into a new substance when in contact with other elements. By the way, if I'm going fast, please feel free to pause so you can fill in your blanks on your note guide. Okay, so obviously reactivity is one of the most common chemical properties. Does X react with Y? You don't know that about X unless you try the experiment. So reactivity is the ability of a substance to combine chemically with another substance, and that's a really good chemical property to know. Again, most of these have already been done before, but if you wanted to find one that wasn't done, you'd have to do the reaction to figure it out. Another really common one is flammability. That's the ability of a substance to react in the presence of oxygen and burn when exposed to a flame. So like, I don't know that this piece of paper reacts with or is flammable unless I try to light it on fire. Like if I didn't already know that, if I hadn't seen it already, or if I hadn't heard about it, you wouldn't know just by looking at the paper. So that's a good example of a chemical property. Chemical properties, there's a table that shows like how they are different. Like for example, baking soda, its physical property is that it's a white powder. So that's just like a thing an observation you can make about it by looking at it. But obviously a chemical property is that it reacts with vinegar to produce bubbles. If you didn't know that, you couldn't tell that by looking at the baking soda. You'd have to do that reaction to see it. Okay. On the other hand, sugar is also a white powder. That's a good physical property for sugar, but this does not react with vinegar. So again, you'd have to try to mix them to see if that was a property of sugar or not. Okay, so that's chemical properties. Let's talk a little bit about physical and chemical changes. In a physical change, you're just changing the matter from one form to another without a change in its chemical properties. So a good example of a physical change would be like smashing a bottle. It's still glass, right? It was a glass bottle before. It's still a glass bottle afterwards. You've rearranged the way it looks. That's a good example of a physical change. Breaking a stick. It's the same stick, you've just broken it into two pieces. Another good example of a physical change, cutting grass. You get the idea, cutting your hair. Oh, those are physical changes that, in theory, might be able to be undone. It's obviously going to be pretty hard to put together all the blades back in your grass or all the glass pieces that you break. But that's the theory, at least. So physical changes do not affect the substance identity, and they affect only the physical properties of a substance. One physical change that people have a tough time with is dissolving. If I dissolve some sugar in water, that's not a chemical change. I can undo that. I can evaporate the water and get the sugar back the same exact way it was before. That is an example of a physical change. So dissolving something in something else that you can undo, that's a physical change because these mixtures can be physically separated and they can be separated based on the physical properties. If we had more time and this wasn't during a pandemic, we would be doing a physical property lab with mixtures, but we don't have time and it's a pandemic. We don't want anyone to get sick. So let's move on to chemical changes. Chemical changes are the opposite. Physical changes, they do rearrange the chemical components or the elemental components of a chemical. These changes occur when a substance changes composition by forming one or more new substances. So in a chemical change, you're making something brand new, or you're making that thing by rearranging the molecules that you had to start with. Chemical changes happen everywhere. And so that's what makes them very easy to talk about. Like, for example, digesting your food or brushing your teeth or the leaves changing color and falling off trees. Those are all chemical changes, and you can see them happen in your everyday lives. Here's some other ones. Anything you burn. Right now, my daughter's having a fire outside with a friend. So those burning logs, you can't get those logs back. That's a good example of chemical change. Rusting metal, can't get the metal back. That's a chemical change. Digesting food, obviously you don't get the food back the way that it went in. And then decomposing anything. All those are chemical changes. Chemical changes always form new substances, and the new substances have new and different properties. That's how you can identify it. If you start with one thing and you change the way it looks and you do some reaction and like now it looks different, that's probably an example of a chemical change. You can always identify chemical changes. When things change color, it's a good example. When something bubbles, like if you take baking soda vinegar, for example, and it bubbles, that's a good chemical change. Not like boiling water, that's not a chemical change, but if you like mix two things together and they start to bubble. Energy transfer, whenever something gets hot or cold, when you like mix two things and they get warm or cool, that's a good example of chemical change. And whenever you form a solid, take two things, mix them together, that would be and it forms a solid, that'd be a good example of a chemical change as well. So you can identify them pretty easily using those four categories. Chemical changes tend to be irreversible, right? You can't unbake a cake. You take your ingredients, mix them all together, put it in the oven, take it back out, and let it sit on your countertop for a while. It's not going to spontaneously go back into eggs, flour, and whatever else, right? So that's a good example of a chemical change that they are typically not reversible. You can break things down through chemical changes, so you can take complicated molecules and make them less complicated, and some of them will undergo chemical change to form elements. You can actually take, like for example, water and run an electric current through it and make it into hydrogen and oxygen. That's a good example of a chemical change as well. Okay, so now you've got a good idea of what a physical change is, what a chemical change is, and what are physical properties, and what are chemical properties. This has been super fun. Good to see you. Bye!